Hello.
Hello, Romario. How are you?
Hello.
Good
Yeah.
morning. How are you
Yeah,
today?
good.
How are
How
you
are you?
today? Very well,
Yeah,
thank
good.
you.
May I ask why is it on record?
Yeah, go ahead, record it.
How comes?
You said?
What do you
So,
mean?
I said you were asking for permission if you could record. I said go ahead, record.
Okay, yeah, thank you.
Yeah, so you can see my screen, right?
Yeah.
So let's get right into what we'll be doing today. How are
Okay.
you doing? How have the lessons been so far?
Yeah, very good. Yeah, good.
All right, so let's get into what we have for today. Let's not waste any time. We're going to be dealing with one of the topics that we had in our lineups, chemical formula, equations, and calculations. Are you ready?
Yeah.
Okay. So, by the end of this lesson, you should be able to do a few things. Okay. First of all, you should be able to define chemical formula and explain its importance in chemistry. And then
Okay,
next,
yeah.
mhm, you should be able to write simple chemical formula for elements and compounds using their valences. Don't worry, I'll explain what valences mean, okay, as we progress. Then
Yeah.
you should be able to differentiate between word equations and chemical equations. In chemistry, equations can be subdivided into two broad types. We have the word equation and then we have the chemical equation. So in today's lesson, we're going to be seeing both of them, and then we're going to be differentiating between the two of them. And then finally, we're going to be learning how to balance chemical equations. Okay, this last one, we're
Yeah.
not going to be doing it in today's lesson, okay?
Yeah.
All right then, so let's proceed. What is a chemical formula? Let me ask you that question. Do you want to try?
Um, is it like a compound like showing different types of atoms?
Um,
Like in their relative numbers, like in their numbers.
okay, very nice
I'm not really
try.
sure on it.
Yeah, that's why I'm here. I'm here to show you whatever you're not sure about. A chemical formula, see what is written on the screen, is a symbolic representation. Take note of that phrase, symbolic representation. You know what a symbol is, right?
Yeah.
Very good. It's the symbolic representation of a compound showing types of atoms, present, and their relative numbers. For example, when I write something like this, what did I just write?
H2O.
Very good. What does this represent?
Um, it represents hydrogen.
H represents hydrogen. But this whole stuff that I just wrote, H2O, as a whole, what does it represent?
Two hydrogen atoms and one oxygen atom.
Good, very good. But there is something that it stands for. When you see H2O, what is that thing that it represents? There is something I want you to mention.
I'm not 100% sure.
Okay, it represents water. Do you remember now?
Oh, no, I'll write this down definitely.
Okay, so H2O is the chemical formula for water. So in chemistry, when we want to represent a compound, we use formulas. So that is the definition. Go ahead and write that down.
Yeah,
Okay.
yeah.
If you're writing something down, let me know so that I won't get ahead of you. A chemical formula is a symbolic representation. Take note of that phrase of a
I have, yeah.
yeah, of a compound showing types of atoms present and their relative numbers. So what do we mean? This is a chemical formula H2O because it is telling us the elements that are present. It is showing us that we have hydrogen. Did you see that?
Yeah.
And then it is also showing us that we have oxygen present. And not only is it telling us the elements that are present, it is telling us how many atoms are present. You mentioned that we have two hydrogen atoms as shown as this subscript of 2 over here. Is that correct?
Yeah.
And then we have one oxygen atom. So that is what a chemical formula is. It is a symbolic representation of a compound showing the types of atoms that are present and their relative numbers. Any confusion?
Um, no, not so far.
All right then. How about this formula over here? Does this ring a bell?
Oh, is the man not like one sodium atom and one chlorine atom?
Okay, good. This is one sodium atom. That's correct. And then over here, one chlorine atom. But then the whole formula, the combination of all of these, it represents something. Do you know what it represents?
Chlorine.
No, it's called, what did I just write?
Salt tastes salt.
No,
Oh, table salt.
very good. So the formula for salt is NaCl. Na stands for sodium, which is just one atom, and Cl stands for chlorine, which is
Yeah.
just one atom as well. Did you see that?
Yes, sir.
All right, so that brings us to the next thing we want to deal with. If we know what a formula is, how do we write it? There are steps that we need to take if we must write a formula correctly, and that brings us to the concept of valency. Okay? Now let's define what valency is. Can you read this stuff that I'm underlining right now?
Um, Let me quickly read it. Valency combining capacity of element. How many electron it gains, loses, or shares?
Read that one more time.
Valency combining
No.
capacity.
Valency
Valency
equals.
combining
No, 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 no. How about this symbol over here? You forget about it?
equals.
Good. So
Valency
valency
equals.
equals the combining capacity of an element. Oh yeah, read it now.
Valency equals combining capacity of an element. How
How
many
did it?
electrons
Hold
it
on.
gains, loses, or shares?
Hold on, Romario. You said something that felt very funny to me right now. How did you pronounce this word over here?
Capacity.
No, capacity. Do you know what
Capacity.
do you know what capacity means?
Yeah, yeah, like a certain amount.
Good. So valency simply means the combining capacity of an element. Let's look at it this way. Different people have different amounts of food that they can consume. Is that correct?
Yeah,
For instance, do you have any siblings, maybe a brother or a sister?
yeah, brother.
Okay, junior or senior?
Young.
Younger. Okay, good. Let's say you and your brother now. What's your brother's name?
Gabriel.
Gabriel. Let's say Gabriel can only eat one slice of pizza and then he'll be satisfied. But
Yeah.
you on the other hand can eat two slices and one Big Mac before you'd be satisfied. So
Yeah, yeah.
if I'm asking the question, who has more eating capacity between the two of you? What would you
Me.
say? Very good, because you can take in more food than your brother. In the same way, valency is just like that. It is the combining capacity of an element. What is that combining capacity and what does it mean? It means how many electrons it needs to gain, or it needs to lose, or it needs to share. Did you understand that?
Yes, sir.
Would you want to write that down?
Yeah.
Okay, good. Go ahead, write that down. Valency is the combining capacity of an element. That is, how many electrons it gains, it loses, or it shares. And I'm going to be showing you how we can calculate the valency of an element. So, in order to use valency to write the formula of a compound, Oh, and by the way, let me ask you to refresh in your memory. What is a chemical formula?
Um, a chemical formula is like a method for like chemical stuff.
No, we just treated that 1 page ago, Romario. Remember what the chemical
Oh,
formula
it's a
is?
symbolic representation.
Of what?
Oh, I didn't write that final part. Should I write it?
Of course, you need to write it down. I thought you wrote it down. That was why I moved ahead.
Oh, I only wrote the first part.
Please write it down. I told you if there's any part you've not written down, call my attention to it so that we'll deal justice to that. Have you written that down?
Almost.
All right, please take your time and write it down.
Okay.
You done now?
Yeah.
All right, very good. So, what's a chemical formula? Without looking at your notes.
A chemical formula is a symbolic representation of a compound showing the types of atoms present and their relative numbers.
Good. Make sure you don't forget, okay?
Okay.
So, here are the steps that you need to take to write a chemical formula correctly. First of all, you need to write the symbols of the elements. That is step number one. Are you
Yeah.
watching? Step number two, you need to write their valencies. I will be showing you how to get the valencies of a compound or of an element. I beg your pardon. And then thirdly, you swipe and balance the valencies. So here is one example. For instance, if someone says, write the chemical formula for water.
Okay.
So the first step to do, step number one, write the symbols of the elements. What are the elements that are present in water?
Um. Oh.
Romario, you can't tell me you don't know this one.
Pardon?
You can't tell me you do not know this one. What are the symbols or the elements present in water?
Um. W.
No. Water. Water. What are the elements present in water? What is the formula for water, Romario? We dealt with that 1 page ago.
Oh. H2O chemical formula is like
Okay.
water.
H2O is the chemical formula for water. What are the elements that are present in water now?
Can I check my notes?
No, I want you to tell me because you won't be able to check your notes in the examination hall. What are the elements that are present?
Hydrogen and oxygen.
Very good. Hydrogen, and the symbol for hydrogen is H, right?
Yeah.
The symbol for oxygen is what?
O.
Very good. Oh, so we have done the step number one. We have written the symbols of the elements. What is step number two?
How many of them there are?
Step number two. I just ticked it now. What's step number two?
Write their valencies.
Good. Now, I'll show you how to calculate valencies, okay? But for this example, the valency of hydrogen is 1. The valency of oxygen is 2. Did you see that?
Yeah.
Good. And then the third step says what?
Swap and balance valencies.
So what we'll do at the third step is just to cross just like this. So the final formula now becomes H took this number 2. Is that correct? Because we crossed it like this, right?
Yeah.
So we have 2 in front of H. And then O stays alone because he took number 1. So we don't necessarily need to write the number 1 like this. We can still write it H2O. Did you see that?
Yeah.
Did it confuse you?
Um, but don't we already know? But how would you know how the valencies of it?
Yes, I said I was going to show it to you, okay?
Oh, yeah. Okay, yeah.
Good. So let's check out this first example. Hmm. Water, which is H2O. How do we know the valencies? Now watch this. This is um This is a picture that shows how the atom of hydrogen looks like. Did you see that?
Yeah.
Good. Now, how many electrons can you see on this shell that I just labeled?
Um, what was that? Sorry, it cut out.
Okay. How many electrons can you see on this shell? This one here.
One.
Good. Just one electron. How many shells are there?
How many shells?
Yes.
Um, two.
No. Check
One.
again. Just one. I told you that this is the symbol. This one over here is the symbol. It's
Yeah.
not a shell. Do you remember from our previous class?
Yes, sir. Yeah, I
Good.
remember.
And I told you that if it is just one shell, how many electrons are needed for it to be fully filled?
Um, One.
No?
Oh, could you explain that again?
Okay.
Like,
I'll explain it one more time. Now pay attention, Romario. We said valency is the number of electrons that an element needs to gain or lose. Do you remember that definition, or should I go back to it?
can you go back to it maybe?
All right, look at it. Did you write it down?
I missed one step. Let me write that down.
All right, go ahead. When you're done writing it down, let me know.
Okay.
All right, then.
Can you explain the cross method, please?
Yes, I'm going to explain it in the next example, okay?
Okay.
Good. So that's the example that we are dealing with right now. Step number one, look at this H2O, water. How do we write down the formula? The step number one says write down the elements, right?
Yeah.
Good. And the elements present are what?
Um, the elements
What are the
are
elements?
hydrogen,
Huh?
hydrogen,
Mm-hmm.
and oxygen.
Good. Hydrogen and oxygen. What is the symbol for hydrogen?
Um, H.
How about oxygen?
O.
Good. The next thing to do is to write their valency. What is the valency? What is valency, by the way? Can you define it for me?
Valency is like combining capacity of an element.
Good. Instead of saying, if you don't feel comfortable using the word capacity, you can also say power, okay? You can say it's the combining power of an element. Now look at this. In this
Can I
case,
say combining amount?
you can say that as well, the combining amount of an element.
Okay. All
All
right,
right.
that instead.
Okay, good. Okay.
Okay, yeah.
Now, so now when we say the valency for hydrogen, we're talking about how many more electrons can it take or how many more electrons can it lose. Now, look at hydrogen. How many electrons does it have?
How many electrons does it have? What one?
Good. How many electrons can it lose?
Can it lose?
Yes,
One.
good. So it can lose one electron. Now remember, valency is the combining amount of an element, the way you define it. And that combining amount means the number of electrons it can gain or lose. So if the number of electrons that hydrogen can lose over here is one, what therefore will become its valency?
One.
Very good. Very, very good. Why is it one? It is one because hydrogen has just one electron, and therefore the number of electrons it can lose is one. Did you understand?
Yeah.
Are you sure you did?
Pardon?
Are you sure you understood what I just said?
Yeah, can you write it in like steps? Because it's getting a bit jumbled up.
All right, then I'll write it down. First things first, we wrote out the elements that we have: hydrogen and oxygen, right?
Yeah.
Good. The next thing to do is to find out their valencies. Valency simply means how many electrons can it gain or lose. So now this is hydrogen. How many electrons can it lose?
One.
Good. So what is the valency?
One.
Very good. So that's why we have one over here. Did you see that?
Could you write it in like steps, like in sentences, so
Okay.
I can remember this?
All right then. So we have hydrogen. The valency. Are you writing it down as I'm writing it down too?
Yeah, of course.
The valency of hydrogen is 1 because it can only lose and gain 1 electron. Have you written that down?
Yeah.
Good. So now I have hydrogen H, and then the
Wait, wait,
valency.
wait, sir, can you go back? I was 2 words away.
Okay,
Gain and gain 1 electron. Okay.
good. So I have the symbol hydrogen and the valency 1 underneath. And then next I have oxygen, the next element. How do I get the valency? Now look at this. Remember, I told you that when an element has more than one shell, the number of electrons that are needed for it to be balanced are 8. Do you remember me telling you that in our previous class?
Yeah.
Do you remember?
Yeah.
Okay, good. So now, how many electrons are here on the outermost shell of oxygen?
1, 2, 3, 4, 5, 6.
Good. There are 6 electrons on the outermost shell of oxygen. I'm glad you're following. But then we need 8 for it to be balanced. Is that correct?
Yeah.
So how many more electrons can oxygen gain?
One. Oh, is it two?
Good. Oxygen has the capacity to gain 2 more electrons. And remember, valency, what is valency?
Valency, is combining amount of an element.
Good. The number of electrons that it can gain or lose. Do you remember that?
Oh, is that what valency means?
Yes, the
I prefer
num
that definition. Can you
oh,
repeat that again,
okay.
please?
All right. I'm going to repeat that in as much as that one serves you better.
Yeah.
So let me write that down on the screen so you can um so this is the definition you prefer, right? Valency is the number of electrons that an element can gain or lose. Do you like this one?
Yeah.
All right, I'm glad you saw the one that you liked. So, if we apply that definition, we have found that the hydrogen over here can lose 1 electron. So its valency is 1. So do you understand how we got the valency of hydrogen now?
Right, wait, can I repeat what I've written?
Yes, please go ahead, repeat that.
So step number one,
Mm-hmm.
hydrogen, the valency of hydrogen is one because it can
Mm-hmm.
only lose and gain one electron.
Yes. Thank
Okay.
you. Thank you. Thank you. Let me teach you a new word. In Nigeria here, one of the languages we speak is Yoruba. When we say Oshe, it means thank you. Can you say that?
Uh-huh. Well, we'll shut. What was
O
that again?
Oshe,
Oshe.
Oshe, yes. Say
Oshe,
Oshe,
Oshe.
Oshe. All right, so I just brought that in for kicks to make the class a bit lively. So valency is the number of electrons that an element can either gain or lose. And we found
Yeah.
that the hydrogen can gain and lose one electron. So that means its valency is one. Did you see that?
Yeah, so what's step number two?
Good. Step number two, we're going to find the valency of oxygen. How do we know the valency of oxygen? First things first, we need to know how many electrons it can gain or lose. Did you understand that?
Yeah.
Good. So now, how many electrons do we have on the outermost shell? Let's count. One, two,
Two,
three,
3, 4, 5,
four.
6.
Good. Five and six. We have six electrons. Did you see that?
Yeah.
Now, how many electrons does oxygen need for it to be fully balanced or fully filled?
8.
Good. It needs eight electrons for it to be fully balanced and fully filled. Is that correct?
Yeah.
Good. So now, if we have just six
Wait, would
electrons,
it be 8? Because on the second shell, on the second like circle, there's
mhm,
two.
on the second circle, which second one
Yeah.
is that? Is it
Uh,
this one over here?
yeah.
No, 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 no. That's the first shell. We're not dealing with that. When we're dealing with valency, we are dealing with the outermost shell, the one
Oh.
that is
So why
outer.
would it be 8 then? Why would you need 8?
No, no, no. We are not we have not said the valency is eight. We are only saying that for it to be fully filled, it needs eight electrons.
Why is that?
Okay, good. Thank you for asking that question. That is something that we call the octet rule. And the octet rule says that for an atom to be stable, it needs to have eight electrons in its outermost shell. Can you write that down?
Okay. Yeah, I'll write this down.
Yeah, go ahead, write it down. I'm glad you're following and I'm glad you're asking all these questions. It shows that you're here to learn.
For an atom to be what?
Stable. Did you get that?
Yeah.
Did you get that?
Yeah.
Okay. When you're ready for me to proceed, let me know.
Yeah, you can remove it now.
All right. Are you sure?
Yeah.
Good. So let me clear out everything and start afresh. So step number one, let's write out the elements that we have. We have hydrogen and we have oxygen. Did you see that?
Yeah.
Now, what is the valency of hydrogen? Let's find out. How many electrons can hydrogen gain?
1.
Good. And it can also lose one electron. So that's why the valency is one. Do you understand?
Oh, it's because that's the total.
Good. That's the total number of electrons
Oh,
that
that's why.
it
Okay.
that's the total
Okay.
number of electrons that it can gain or lose. Now, let me show you something. If an element has only one shell,
Yeah.
The total number of electrons it can take is 2. Can you write this down? If an element has only one shell, the total number of electrons it can take are 2.
Okay. So is this a definition?
This is not a definition of anything in particular. This is just one fact I want you to know because we're going
Okay.
to apply this to hydrogen. How many shells can you see on hydrogen?
One.
Very good. How many electrons can it take?
One.
Good. It can. No, 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 Romario. No. It has just one shell. And I told you that if an element has one shell, the total number of electrons it can take is what?
Two.
Good. So hydrogen, how many shells does it have?
Um, one.
Good. One shell. How many electrons can it take?
Wait, can I just finish writing this?
Okay, go ahead. Go ahead, write it.
Right, can you label one of the circles? So like what would this be called? And like what would this be called? And like what's the overall name for this whole thing?
Okay, okay, all right then. Let me label it for you. So this right here, the whole drawing, okay, is called an atom. Did you see that?
Okay.
Did you see that?
Yes.
Good. It's called an atom. So here are the individual parts. This small circle you see over here is called an electron. Okay?
Yeah.
Good. And this right here is called a shell.
Okay.
Good. And this ball, this big ball you see in the middle, okay, that has H written on it, is
Yeah.
called a nucleus.
Okay. Okay, so now what would the second step be?
Good. So the first step is we have written the symbols of the elements, hydrogen and oxygen. The second step is to find out the valency. And that step is what I'm showing you right now. Okay? Hello, are you there?
Yeah.
Good. So hydrogen, how do we know the valency? The first question we need to ask ourselves is how many more electrons can it take? How do we know that? First of all, we look at the number of shells that it has. How many shells can you see, Romario, on hydrogen?
Um, on hydrogen.
Mm-hmm.
One.
Good. I told you a shell is this line of circle that has this ball on it. Okay?
Yeah.
That's what a shell is. So hydrogen has just one shell. And if an element has one shell, the total number of electrons that it can take are 2. Did you get that?
Yeah.
Good. So it's just like saying if I have one stomach,
You just add an extra.
if I just hold on, if I have, let's say this shell now is my stomach. If I have one stomach, the total number of pizza I can eat are 2 pizzas. Is that
So it's
correct?
just double each time.
So now, hold on. Let me
So
give.
let's say if I have three shells,
Mm-hmm.
it would be four.
No, 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 no. We don't calculate it like that. So the formulas we use to calculate the number of electrons that a shell can take is this formula, 2n squared.
Yeah.
So look at this now. This n here represents the number of the shell. So hydrogen here has only one shell. Is that correct?
Yeah.
Romario, are you lost?
Well, I just want to know like what the second step is.
Yes,
It's
that's
like getting too muddled up now.
okay. So let's take a deep breath and go over it one more time. Okay?
I just want to know the second step.
Yes, that's what I'm showing to you.
Oh.
So the first step, we have written down the symbols H and O. That's for hydrogen and oxygen, right?
Yeah.
Good. The second step, the valency. What is the valency of hydrogen?
In hydrogen one.
Good. Do you know why it is one?
Um, why? It's because there's one only.
No, because
There's
hydrogen,
one electron.
no, because hydrogen can only gain and lose one electron.
It can only gain
Remember,
or lose one electron.
yes, remember I told you valency is the number of electrons that an atom can gain or lose. Do you remember that definition?
Oh, you said that an element can gain or lose.
Yes. Do you remember now?
Yes, sir, I remember.
So now we want to find out the valency for oxygen. In other words, we want to find out the number of electrons that it can gain or lose. Did you understand?
Yeah,
Good. So how do we know the number of electrons it can gain or lose? When we want to find that out, we come to the outermost shell, the shell that is most outside, that I just labeled now. Did you see that?
yeah.
Now let's count the number of electrons that we have. One,
One, two,
two,
three, four, five, six.
good. So we have six electrons, but that is not the valency, okay?
Yeah,
Good. The valency is the number of electrons it can gain or lose. So now there are six electrons. And remember, I told you that for an atom to be balanced, the number of electrons that must be on its outermost shell are how many?
um, to be on its outer shell.
Yes,
Eight.
good. Eight electrons.
There'll
So,
always be eight for any electrons now.
yes, apart from hydrogen, because hydrogen has just one shell, is
Okay,
always eight. So now we need eight electrons, but oxygen has only six. So how many are we missing?
two.
We are missing two. So that means oxygen can gain two more electrons. Did you see?
Okay,
So that means oxygen can gain two more electrons. So that tells us that the valency of oxygen is two. Why?
yeah,
Because oxygen can gain two more electrons for it to have eight electrons in its outermost shell. That is its
yeah,
valency. Did you understand that?
yes, sir.
Are you sure you did? I don't want you to be
Yeah. Can
good.
you write a sentence for step two, how you done for step one?
Okay, so for step two, to figure out the valency, we need to know how many electrons an atom can gain or lose. So now, Romario, let me give you a very easy way to know the valency um
Yeah, sure.
of an atom. Once you have an atom, if it is not hydrogen, if it is hydrogen, okay, the valency is always one, okay?
Yeah,
Once it is hydrogen, but any other element apart from hydrogen, if you want to know what the valency is, just count the number of electrons that are on the outermost shell. One, two, three, four, five, six. And then ask yourself, how many more electrons are needed for it to be complete to eight?
okay.
So how many more are needed for it to be complete to eight?
Two.
Good. So the valency is what?
8.
No,
6.
no. You just
2.
said it now.
2.
Romari, I told you. The valency of an element is what?
2.
No,
8. You need
mm-mm.
8 in total.
No, the valency of an element is the number of electrons that it can gain or lose. Do you remember that?
Yeah, I remember that.
Good. So now we have counted the number of electrons we have here, and it is
And
6.
there's 6. And then we need 2 more to get to 8.
Yeah, we need two more to get
That's
to it.
what I
So,
said.
yeah, the valency is 2. You were saying 8 initially, and I was confused. Are you there now?
Yeah, I know what I'm doing. Yeah.
All right, good. So, for hydrogen, the valency is 1, and for oxygen, the valency is what?
Um, Let me count it. 2.
Good. 2. So that's step number 2. Step number 3 says do a cross like this. Did you see that?
Yeah.
So when we cross like that, we're going to write all the symbols step by step. We have H. So what number did H cross to?
Um, O. Oxygen.
Mm-mm. The
To
number that
2.
H, yes, H crossed and took number 2. So we have 2 in front of H. Did you see that?
Yeah.
And then we have the next letter, which is what?
O.
And
Oxygen.
what number did O take?
1.
Good. So we can either write it like this, 1, but usually in chemistry, when it is just 1, we leave the letter like that. So that's why we have H2O.
Yeah.
Did you see that?
Yes.
Can we take one more example?
Okay, yeah.
All right, so the next example that we have is sodium chloride. Now, I want you to watch this example closely. What is step number 1?
Um, Wait, I'm just writing it. All right, step number 1 is hydrogen. The valency of hydrogen is 1 because it can only lose and gain 1 electron. So you
Mm-hmm.
need to figure out the valency.
Okay, so we are dealing with another new question now. No longer hydrogen and oxygen. We're dealing with
Okay.
sodium chloride. So what is the first step?
The first step is we need to figure out the valency.
Mm-mm. The first step is to write out the symbols. It's there in your notes now, Romario.
Pardon?
The first step is to write out the
Oh, you
symbols.
never. That wasn't on the thing on the step you told me to write.
Oh,
Yeah, can
oh,
you rewrite it then? Because it's getting a bit confusing.
hold on. Didn't you see the steps here? Steps for writing a formula. Write the
No,
symbol.
but I wanted it in more detail, remember?
Okay, okay. So when you want to write the formula of a compound, this first step is to write out the symbols.
All
Step
right.
number 1. So let's write out the symbols. We have two symbols. What are they?
Um, Sodium chloride.
So what are the two symbols that we have?
Wait, can you go back, please? One slide.
Okay, okay,
I just want to rewrite it so then I can remember this.
okay. Go ahead. Yeah,
Because
go
I
ahead.
don't want to keep on repeating it every lesson.
All right, sure, sure. Go ahead.
All right, give me 5 minutes
All
or
right, sure,
2.
sure, sure. Are you done?
Almost.
All right then.
Sorry, sir. I just wanted to make it clear.
Yeah, sure. Go ahead. Take your time.
Sorry, almost done.
All right then.
Right, can I quickly just take a picture and send it to you to see if this is right?
Now, of the notes you took.
Yeah.
You send it to me on WhatsApp, okay? After the class, so that we'll not get distracted.
No, but I just want you to check if it's all good.
All right then. All right, send it. Where are you sending it to?
WhatsApp.
Okay. Yeah, go ahead, send it.
Ah, I've sent it.
Hold on, I'm trying to log in on my PC.
Okay. Yeah, I just want to get it right so then we can start new topics.
No, no problem. What new topics are we going to be handling?
I've sent my mum should have sent it to you.
Yeah, she did.
Yeah, so I think that's it.
Okay, writing formula. Write the symbols of the elements. We need to know how many electrons an atom can gain or lose. We know hydrogen is one. Oxygen needs two as every. That part where you wrote every atom must have eight. Complete it by
Ah,
saying every atom needs to have eight on its outermost shell.
on its
Every atom needs to have eight on its outermost shell. Eight electrons on its outermost shell.
okay, yeah. Other than hydrogen.
Yeah.
Okay. Is the rest okay then?
All right. Can we proceed?
But is the third step okay?
Yeah, can we proceed now?
Yeah, yeah, but I'm asking like, is the third step okay on the thing I said?
Okay, okay. Yeah, yeah. The third step is okay.
Oh,
Perfect.
all right. Yeah, we can proceed.
All right. So now this is sodium chloride. What is step number one?
Write the symbols of the elements.
Okay. What are the symbols of the elements?
Um, Na,
Na stands for what?
Sodium.
Good. And then the other one is what?
Chlorine. Chloride.
Chlorine. Okay, not chloride, chlorine. That's the
Okay.
name of the element. What's the symbol for chlorine?
C.
No,
Cl.
Cl. Next thing to do is to write the valency of the two of them. How do we know the valency? Remember, valency is what?
Valency is the number of electrons that an atom can gain or lose.
Thank you. Perfect. The number of electrons that an atom can gain or lose. Now, look,
Okay.
yes, now look at sodium over here. The outermost shell, this one.
One.
How many electrons are there?
One.
Good. How many electrons can it lose?
One.
Good. So what is the valency?
One.
Very good. Any confusion as to how we got the valency of sodium?
No. Okay. All good. Yeah.
Good. Now, chlorine. Look at the outermost shell. Did you see that?
Yeah.
Good. How many electrons are there?
One, two, three, four, five, six, seven.
Good. We have 7 electrons, right?
Yeah.
Good. So now, how many electrons does it need for it to be fully balanced?
It only needs one.
Okay, it needs 1 electron for it to be fully balanced because every atom needs to have 8. Is that correct?
Yeah.
So now we have only 7. So that means it's missing only one.
Yeah.
Good. So what's the valency of chlorine now?
Um, eight.
Calm down. Let's take that one more time. The number of electrons that chlorine needs. Remember, valency is the number of electrons it can
Six.
gain. It can gain or lose. Calm down, Romario. Let's take that one more time. The number of electrons that it can gain or lose. That's valency, right?
Yeah.
And we found out that for sodium, the number of electrons it can lose is 1, right?
Yeah.
Good. So now this is chlorine, the second one. How many electrons are there on the outermost shell? We said 7, right?
Right.
Good. And for it to be fully filled, we need it to have 8 electrons. Is that so?
Yeah.
Good. So for it to move from 7 to 8, how many electrons can it gain?
One.
Good. It can
That's what I
gain.
said.
You said 7.
No, I said one.
Okay, what's the valency of chlorine now?
Um, eight now.
That's the point where I'm saying the valency is not 8. The valency is 1 because it can only gain 1 electron.
Oh, so it only shows how much you can gain.
Yes, the valency, we are using the definition here. The valency of a or an element is the number of electrons it can gain or lose.
Okay.
And we found out that over here, the number of electrons it can gain is 1. That is why the valency here is 1.
Okay.
Did you understand that, or should I take it again?
No, 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 I understand now.
All right, so now that we found out the valency of both sodium and chlorine, what is the next step?
You do the swap method.
Okay, good. Let's swap. So when we swap, we have Na. What number does it take?
One.
Good. And we have Cl. What number does it take?
One.
Good. Now, when it is just 1, 1, it stands we really don't need to write the numbers. You remember that, right? So we can just write it like this, NaCl. If it is just,
Okay.
yeah,
Yeah.
if it is the number 1 standing in front of an element, we can
But
just,
can you write it like that if you want to?
um, in chemistry, we really don't accept that. If it is 1, you just write this symbol like that.
Okay. Yeah.
Don't put the 1. Did you
Okay.
understand? Did you understand what I just did?
Okay. Yeah.
Are you sure?
Yes, sir.
Okay, so let's move on to another example.
Okay.
Carbon, carbon dioxide. CO2. What is step number one?
Step number one, carbon dioxide. Oh, step number one is to write the letters out.
All right, the symbols of the elements.
Symbols, yeah.
So the first symbol is carbon, which is C, right?
Yeah.
And then we have oxygen, which is O. Did you see that?
Yeah.
Good. So the next thing to do is to find out the valency of um both of them. So for carbon, let me show you the what the outermost shell of carbon looks like. We have the nucleus, which is this C that I wrote over here, and then this is the outermost shell of carbon.
Yeah.
Okay, so on carbon, the outermost shell has 4 electrons. One,
Yeah.
two, three, four. Now remember I told you the number of electrons that are needed for it to be fully stable. How many are they?
Four. Three.
No, no. The number of electrons needed for an atom to be
Five.
fully stable.
Five. But like, yeah, eight, but then like you need five extra to make it to eight.
No. How many are here? One, two, three, four.
Oh, four, sorry.
So how many more do you need?
Four.
Good. So that means that carbon can gain four.
Gain four.
Yes, 4 more electrons. Is that correct?
Yeah.
So now what is the valency of carbon?
Four.
Good. 4. Why is it 4? Because carbon can gain 4 more electrons.
Yeah, it can gain four.
Good. Now, what is the valency of oxygen? We've already dealt with this in the previous question.
Um, six.
No.
It can gain.
You want me to draw it out for you?
Yeah, that would be helpful.
Okay. So this is what the outermost shell of oxygen looks like. We have the symbol O in the middle, and then this is the outermost shell. Oxygen has one, two, three, 4, 5, 6 electrons in the outermost shell. So now there are 6 electrons in the outermost shell. How many more does it need to
Two.
make? So what's the valency?
Two.
Good. So we have 2.
And then you do the cross method.
Good. So let's cross it now. So when we cross it, what do we end up having?
Um, Oxygen is four.
We start with the left-hand side.
C2,
Good. C2. And then
O4.
good. O4. Now we won't stop here. Okay. This is what we're going to do. Look at these two numbers. We have 2 and 4. There is
Yeah.
something called divide to the lowest term. Have you ever heard something like that before?
No.
Okay, divide to its lowest term means we're going to take it to a point where there is no single number that can divide the two of them. Now, look at these two numbers. We have 2 and then we also have 4. Are there,
Yeah.
is there any number that can divide both 2 and 4?
Two.
Yes, 2 divides 2.
So one and two.
Good. So 2 divides 4.
So it's just simplifying it.
Yes. Oh, thank you. We're simplifying it. That's
Okay.
the word. So we have C, simplifying it, this becomes 1. And then we have O, simplifying it, this becomes.
Okay, yes, yes. Can you write simplify on the side? I'm gonna take a picture.
Okay, all right. Simplifying,
Okay, yes. This is
s-
much easier now.
simplifying it. So remember, I told you if it is 1 in front of an element,
Yeah.
we just write it like that. Okay?
Okay, yeah. Thank you.
So therefore, it now becomes CO2.
Yeah.
So that's why the formula for carbon dioxide is CO2. Did you see that?
Okay, yeah.
Are you sure you saw it?
Yes, 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 I can
All right.
see it, yeah.
Can I give you one question to try?
Yeah, go on.
All right, then do this one. Um, I want you to do this one.
Okay.
Magnesium chloride. But hold on, before you start doing it, let me bring let me
Can you
um
draw it out?
yes, let me picture it out first.
Yeah, so can I have these for homework then, please?
All right, then I'll draw the um
So if you draw the circle things at the atom,
yes. I'll
and then the question thing, send it to me and I'll do it for homework.
all right then, no problem then. Okay, I can do that. We can do that. So
Oh, should I answer this, Ben?
no. Don't answer. Just hold on. I'm going to draw the circle,
Ah,
like at
okay.
the atomic pictures of both of them, and then you can do that as homework.
Okay. Oh, so I'm not answering anything right now.
Huh?
So you're just gonna set these for homework, yeah?
Yes, I'm going to do that.
Oh, okay then. You can send that and yeah, we'll talk during the week.
All right then. No problem,
Thank you.
Mario. It's no problem.
Bye.
You take care.